Hi, in this video we're going to take a conceptual data model and convert it to a set of relations using mapping. So we're going to map our entity types and map our relationship types. So the example we're going to work on is the example we would have worked on in the first week, so our gym example. So here we have entity types: membership type, member, class, trainer, equipment and payment. And then we have relationships between some of the entity types. So for example, member is related to payment, membership type and class. So we need to map those relationship types also. So the first thing we'll do is we'll map the entity types, and each of the entity types there's 6 of them, will become relations, and the attributes of each of those entity types will become attributes of the new relations, and the primary keys will be the primary keys of the new relations. Again, if there's composite attributes such as name, we just translate the first name and the last name. So we're going to transform the above conceptual data model into a set of relations. So firstly, we'll map all the entity types into a set of relations. So the first one there we have is membership type. So the attributes are membership and price, and the primary key is membership. Then we map member. So we've member ID, first name, last name, street, town, county, phone number, email and date of birth. And the primary key is member ID. Then we have class with class ID, class description, the day, the time and duration of the class, and its primary key, which is class ID. We have trainer, or PPS, first name, last name, street, town, county, phone number, email address, date of birth, salary, qualification and specialty, primary key PPS. We have payment, payment ID, date and amount, and primary key payment ID. And then we have equipment, serial number, description, the date purchased, make, model, and the primary key is serial number. So they're all our entity types mapped into a set of relations. Now I've left all the relations open in case we're going to map in any foreign keys. If we left it as it is, we'd have we'd have relations, and then when we implement it in SQL, we'd have tables of membership types, members, classes, etc. But we wouldn't know which classes a member attends, what payments they've made, what membership they belongs to, who trains the classes, what equipment is used in the classes, or etc. So therefore we need to map our relationship types. So secondly, we're going to map the relationship type. So the first one is a has relationship, and that's between membership type and member, and it's one to many. So if it's a one to many relationship, we map the one side is a parent, so membership type is parent, member is many, so we map the primary key from the one side into the many side. Okay, so since this is a one-to-many relationship, we post the primary key from the one side into the table on the many side as a foreign key. So into member we put membership, and that becomes a foreign key. So foreign key membership references the membership inside the membership type relation. The makes relationship then is a one-to-many relationship between member and payment. So again, this is a one-to-many, so we post the primary key from the one side into the table on the many side. So member ID goes into payment, and that becomes a foreign key. Our next relationship then is joins. So the joins relationship is between member and class, and that's many to many. So since it's a many to many, we can't post, so we need to create a new relation. If the relationship has attributes, that will go into the new relation. So since this is a many to many relationship, we create a new relation. We post the primary key values from both tables into the relationship, from the two tables involved in the relationship into the new relation, and they will act as foreign keys, and the relationship attribute is also placed. So we have member ID, class ID and date joined. We have a composite primary key of member ID and class ID, and then both member ID and class ID are foreign keys of the respective tables. Our next relationship then is uses, and that's again between class and equipment. So this is a many to many, so we again create a new relation, and the primary key of class and the primary key of equipment are two of the attributes of this new relation. Both class ID and serial number then is a composite primary key, and then class ID and serial number are foreign keys again of their respective tables. We have instructs then, that's between trainer and class. So again, we're back to a one to many, so the primary key from the one side, which is PPS inside in trainer, that goes into class as a foreign key. So since this is a one to many, the primary key from the one side goes into the many side, so into class goes PPS, and that references the PPS inside the trainer table. So our full set of tables then are membership type, membership and price, and the primary key is membership. And then in the member table we have member ID, first name, last name, street, town, county, phone number, email address, date of birth, and membership, and that membership is a foreign key, and that links us back to the membership type that a member belongs to. Then we have payment ID, date, amount, member ID, the primary key, payment ID, and we have a foreign key then as well, which is member ID. So basically for every payment, we have a link to the member who made that payment. For every trainer then we have their PPS, first name, last name, street, town, county, phone number, email address, date of birth, their salary, qualification and specialty, and they have and the primary key is PPS, and there's no foreign keys there. But for every class then we have a class ID, the class description, the day, the time, duration, and we have the PPS of the trainer who trains the class. And then for joins, then that links the member and the class table, tells us which members are doing which classes and the date they joined. We then have a list of equipment with serial number, description, date, purchase, make and model, primary key, serial number. There's no foreign keys there, but we the equipment, the serial number is involved in another table, and that is linking it back to class, and it tells us what classes they're using which equipment, and both of those then are foreign keys back to their respective tables. So there's your full set of tables. So from that you'll be able to ascertain the members, what classes they're doing, who's teaching the classes, what payments were made, what equipment is used in classes, etc., because of the foreign key, primary key link. So lastly then we'll finish up with a different example here, and we have our customer, repair job, supplier, mechanic and part, and it's for a garage, and we can see the primary key of each of the tables there, and some of the attributes are composite, and then we have relationships between them. So a customer will submit may submit many repair jobs, and a repair job is submitted by one customer. A repair job is worked on by at least one mechanic, and a mechanic may work on many repair jobs, so that's many to many. A repair job can use many parts, and a part can be used in many repair jobs, again many to many. And then a supplier will supply many parts, and a part will be supplied by one supplier. So what we'll do now is we'll translate that into a set of relations. So I'm just going to switch in here now. So I have a text box open, so we're going to put in our new relations. So we have customer, so we have customer ID, first name, last name, street, town, county, and contact number. There's something there, it shouldn't be there. Okay, and then our leave it open, primary key, contact number. Okay, then we have the repair job. So we have job number, job date, and reg number, and primary key, job number. We have mechanic, and for that we have their staff number or staff ID, their name, which is made up of first name and last name, and their hourly rate. And again, primary key, staff ID. Then we have part. So for every part we have a part number, description, stock quantity, cost price. Yep, and primary key, part number, and then we have supplier. And for that we have supplier number, first name, last name, so, and street, town, county, and contact number. So I'm going to copy down all those. Fax number, and the email address. Primary key, supplier number. Okay, we just switch back in here now. So we're going to now map the relationship type. So the relationship between customer and repair job is one to many. So the parent is the one side, which is customer. So customer ID goes into repair job as a foreign key. So customer ID goes into repair job as a foreign key. So here then we'll do foreign key. Customer ID references customer ID. Okay, so that for every repair job then you have the job number, the date of the job, the reg number and the customer ID of the customer who submitted the job. And we want to know who that customer is, we can join it back with the customer table. Okay, the next relationship then we look is repair job and mechanic. So that's a many to many relationship. So therefore, and we have a relationship attribute time, so therefore we need a new relation. So come down here and we do works on. So into it then we put job number and staff ID time. So primary key is a combination of job number and staff ID. And then foreign key, job number, references, repair job, job number. And we have foreign key, staff ID, references, mechanic, staff ID. Okay, we switch back in here then, and we have uses. A repair job uses many parts, and a part is used in many repair jobs. So uses, so a job number and part number, and we have quantity as well. So primary key is a combination of job number and part number. Yep, and then both of them are individually are foreign keys. So foreign key, job number, references, I have that already, so references, repair job, job number, and then foreign key, part number, references, part, part number. And then lastly, our relationship between supplier and part, and that again is a one-to-many relationship. So supplier is the parent, so supplier number will go into part as a foreign key. So part, up here then we do supplier number, so copy that, put that here, and then foreign key, supplier number, references, supplier number. So now we have our full set of tables. So we have customer, we have the repair job, we have the mechanic, we have the part, we have the supplier, and then we have works on and uses. So if we want to know who about the repair job, who the customer is and what parts are used. So we can link up the repair job and customer through the primary key foreign key link. If we want to know what parts are used, then we can go through the users table, join it with the users table, and then the users table can join with the part table. So you're linked. The repair job is linked to users through the job number, and then it's linked to the part through the part number in the users table. So we can link up all our relations like that. So that's our conversion for our conceptual data model into a set of relations for our garage example. Okay, thank you.